Welcome back to The Explainer, everyone. Today, we are going on a really fascinating journey, and our main character is something incredibly small, yet totally game-changing. I'm talking about the sparkling wine bubble. We've all seen them, right? Dancing gracefully in a glass at weddings or celebrations. But today, we are going to unpack the rigorous science, the chemistry, and the sheer meticulous artistry that actually brings them to life.
So it really begs the ultimate question. What makes bubbly, well, bubbly? I mean, it feels like pure magic when you pop that cork. But I promise you, there is some serious science going on in there. We're going to demystify the craftsmanship behind that fizz and see exactly how a quiet, still liquid transforms into this incredibly dynamic sensory experience.
Here is our roadmap for today's explainer. First, the magic of the bubble. Second, production, creating the fizz. Third, fueling fermentation, dry inputs. Fourth, decoding sweetness levels. Fifth, the physics of the pop. And finally, the sensory experience.
All right, let's jump right into section 1, the magic of the bubble, the fundamental science of the fizz. Okay, so carbon dioxide, or CO2. Now, you might think it's just an aesthetic feature to make the drink look pretty, but it's absolutely not. It's the vital active ingredient of the wine. It's a dissolved gas that completely alters how the wine actually feels on your palate and how it smells. Without CO2, you literally just have a flat, still wine. The CO2 is the engine that drives your entire sensory perception of the drink. Moving right along to section 2, production, creating the fizz, how the bubbles actually get into the bottle. There is a massive contrast in how these bubbles are made. Naturally, sparkling wines produce their CO2 organically, right through the biological process of fermentation. This is what gives you that significantly higher quality, deep aromatic complexity and a texture that actually lasts. On the flip side, you have carbonated wines. This is where CO2 is literally just pumped in artificially. It's a low-cost, lower-quality drink, and honestly, those artificially injected bubbles disappear just as fast as the fizz in a cheap soda. If you want true quality, natural fermentation is the only way to go. So how do we get those amazing natural bubbles? Well, the absolute pinnacle is the traditional method, famously known as method champenoise. This is an artisanal, highly controlled, and super time-intensive process. Step 1 creates the still base wine. But step 2, that's where the magic kicks in. You have a second fermentation happening right inside the very bottle you eventually buy. They trigger it by adding a precise mix of sugar and yeast called the liqueur de tirage. As the yeast eats the sugar, it naturally creates CO2. And because the bottle is sealed shut, boom, the gas is trapped. Later, through a delicate process called riddling, all that dead yeast sediment is wiggled down to the neck of the bottle. It's forcefully removed during disgorgement, and the bottle is topped off with a final liquid called the liqueured expedition. It's painstaking, sure, but it creates the finest, most beautifully persistent bubbles you can imagine. Now, there are other ways to produce fizz, of course. The ancestral method is actually the oldest technique out there. The wine is bottled before the first fermentation even finishes, which gives you these really fresh, soft bubbles. Then you have the Shermat or tank method. Here, the second fermentation happens in a giant pressurized tank instead of individual bottles. It's a lot faster, way more economical, and gives a crisp, light style. After that, there's the transfer method, basic gas injection, which as we know is the lowest quality, and even industrial continuous fermentation systems. But let's be real, none of these alternatives ever quite achieve the sheer, nuanced complexity of the traditional method. Section 3, fueling fermentation, dry inputs, the non-liquid ingredients that feed the process. To create that crucial liqueur de tirage we were just talking about, you need sugar. Think of sugar as the absolute food source here. You also need yeast, our tiny biological worker that actively converts that sugar into alcohol and our precious CO2, adding all this rich aromatic complexity while it works. And finally, fining agents and stabilizers. These clarify the wine, removing unwanted particles. It's this incredibly precise, delicate biological dance that naturally traps our hero, the CO2 bubble, right inside the bottle.
9. That is the strict minimum number of months required by the European Union for a traditional method sparkling wine to age on its lees, which are those dead yeast particles we just mentioned. 9 whole months. Now, why so long? Simply put, real quality takes time. The longer the wine hangs out with the yeast, the more structurally and aromatically complex its flavor profile becomes.
Which brings us to section 4, decoding sweetness levels, how sugar defines the final style.
So the official EU classification for sweetness is actually determined by that final addition of sugar, known as the liqueur d'expedition. This scale is brilliant because it lets you, the consumer, easily navigate to the exact style you want. You can start with a bone-dry Brut Nature, which has practically zero sugar, less than 3 grams per liter, all the way down the scale to a noticeably sweeter semi-dry or sweet wine. And by the way, that sugar doesn't just make it sweet. It essentially acts like seasoning to perfectly balance out the naturally high acidity of the base wine.
Section 5. The physics of the pop. The science of pressure and flow. Okay, put on your lab coats for a second because we have to talk about a concept called rheology. This is the scientific study of flow behavior. When we talk about sparkling wine, rheology looks at viscosity, surface tension, and elasticity. Now, why does this matter to you when you're just trying to enjoy a drink on a Friday night? Because rheology is the secret scientific reason behind why a high-quality foam feels so incredibly luxurious and creamy on your palate. It dictates that rich mouthfeel and the very stability of the foam itself.
Let's look at the highly dynamic life cycle of our little hero. It all kicks off with formation, usually starting at a microscopic scratch or a tiny imperfection in your glass. Then it experiences rapid growth as it absorbs more and more CO2 from the liquid around it. Next is the rise where it floats straight up to the top. And finally, the burst. And listen, that burst is absolutely crucial. It's essentially a tiny physical explosion that launches complex, volatile aromatic compounds right up into your nose. So the underlying physical reality here is gas equilibrium. Basically, CO2 dissolves best when the liquid is kept really cold and under extremely high internal pressure. And this perfectly explains why that bottle has to be sealed so aggressively with a thick cork and a metal wire cage. The pressure inside that glass bottle is intense, forcibly keeping the gas totally dissolved in the liquid until the exact second you pop it open.
And finally, Section 6. The sensory experience. Pouring the perfect glass.
Remember that comparison we made earlier about natural versus artificial production? Well, this is exactly where it pays off visually in your glass. That painstakingly slow, traditional method rewards you with a distinctly high-quality experience. Fine, incredibly numerous bubbles with a really long-lasting persistence. Conversely, those lower-quality gas-injected methods, they just give you large, sparse bubbles that completely lack any real stability and go flat super quickly. You can quite literally see the quality of the craftsmanship before you even take a single sip. When you finally pour that glass, you immediately notice the bubble ascent. Because the gas is less dense than the liquid, bubbles quickly rise up, forming these gorgeous, delicate chains that the French romantically call the rosary. As they rise, they're literally acting like tiny microscopic elevators, transporting aromas upwards. Then you have the bubble lace, those elegant, almost frosty residue patterns forming on the inner walls of the glass, which is a direct result of surface tension. The bubbles are actively, physically interacting with the wine, carrying volatile compounds directly to the surface, and massively enhancing your overall sensory experience of the drink.
I love this quote because it perfectly summarizes everything we've talked about today. Bubbles contribute to freshness, lightness, and a balance of sweetness and acidity. Think about that for a second. The physical bubble itself is what unites the chemical inputs of sugar and acid, creating a perfect structural harmony on the human palate.
It's honestly quite an epic journey for a tiny pocket of gas, isn't it? From yeast and sugar interacting in a cold, dark cellar, to the intense physics of a highly pressurized bottle, all culminating in that gorgeous release of aroma right in your glass. Next time you raise a glass to celebrate, I really want you to look closely at those rising chains and ask yourself, how was your bubble born? Thanks for hanging out with me on this explainer. Keep feeding your curiosity, and I'll see you next time.